screen configuration. Okay, I think we were supposed to do the last two pages. So page number 18. So let's see. Okay, class 1 and 2, let's see. Number electric field lines 18, 19. Okay, so I think we will get started with question number 19. 19, maybe we already did it in the last class, right? So let's see. Question number 18 is here. 19, where is it? Yeah, question number 19. I remember doing this. Question number 20, 21 done. So maybe we have to do question number 22. Number 22, let's see. 3-point charges plus q minus q and plus q are placed at points x is equal to 0, y is equal to a, z is equal to 0, x is equal to 0, y is equal to 0, z equal to 0 minus q. Okay, and z, I see z is equal to 0 everywhere, so that means I can plot only x and y alone. So let me plot x and y. So 0 comma a, so that means 0 comma a is somewhere here. So here you have a plus q. And minus q at 0 comma 0, so that means here it is minus q. And a comma 0, so a comma 0 means somewhere here. So that is a comma 0, so you have another plus q here. Magnitude and direction of the electric dipole moment vector of this charged assembly are. So this is 0 comma a, this is a comma 0. So I would assume that the center of the plus is somewhere in the center here, y is equal to x line. So I think it will be somewhere in this direction. The center is going to be somewhere here. So half of this and half of this. So I think it will be a comma a by 2 comma a by 2 would be the point here. So I would assume that that is my center of the positive charges, because here and here, and then minus q is here. So that means the minus p will be directed from minus to plus. So magnitude and direction. So magnitude will be half of this q by this q, so 2qa. A by 2. Let me switch off the fan probably. Okay. So I can assume that 2q is kept over here, actually plus q. So 2qa magnitude direction of the electric dipole moment. So qa along the line joining the points 0, 0 to 0, positive x direction, positive y direction. This does not sound correct to me. Positive x direction, positive y direction. QA along the line joining 0, 0, A, A. Yeah, A, is somewhere here. So that means it should be around this line. So this is also A, A. This is also A, A. So that means direction wise, I would say these two things are correct. Because this is your y is equal to x line. So A, A is somewhere here. So that means the direction is like this. But how to find the magnitude here? So magnitude will be q and q, so it's going to be here q. So q, this is a by 2. So this is a by 2, this is a by 2. So basically I need to find this distance from here to here, this distance. Because this is my origin here, or minus q here, and plus q is here. So that means this distance would be square root of a by 2 the whole square plus a by 2 the whole square, which is nothing but a by 2 will come out commonly and then root 2 will be there. So that means it will be root 2 into a by 2, which means root 2 and 2 will cancel to give me a by root 2. So that is the distance between plus and minus. So that means q into the distance between them. Distance between them is a by root 2. So that's what I'm getting here, qa by root 2. I think maybe some question is wrong here. Give me a sec, let me check that. Root 2 qa, maybe it is 2q. Maybe this is not minus q, it is minus 2q, I think. Okay, let me double check that. Just checking if it is correct. Let me double check that. Problem number 22. Okay. Yeah, actually it is minus 2q. It's a mistake there. So since it is minus 2q, resultant will be. Okay, so make a correction here in the question. It's not just minus q, it should be minus 2q. Why? Because here you have q and q, which means here I should assume plus 2q, which means here also I should have minus 2q. Only then this will be a correct thing. So if that is the case, I will not put q here, I will put 2q. 2q means 2 and root 2 will cancel, so I'll get root 2 qa. So that means this is my correct answer. Okay. So this is one method. As I always told you, sometimes it is better to learn more than one method. So method 2 would be, again method 2 is also very easy. You have minus q here plus q here. That means you will have a dipole moment this way. You have a minus q here and then you have a plus q here, which means you will have a dipole moment this way, minus q2 plus q. So that means the resultant will be somewhere here. So let's call this as P is equal to 2Q. So Q into 2A. So it's actually Q into the distance between them. The distance between them is A. So that means actually it will be Q into A, not 2A. Because the gap between this and this is only A. Right? Between this point and this point. Similarly, the dipole moment in the vertical direction is Q into A. Because this is also A, 0, comma A point. So that means your resultant P resultant will be P resultant is equal to square root of P1 square. Let's call this as P1 and P2. P1 square plus P2 square. But luckily the magnitude is same. So that means I can write this as square root of QA the whole square plus QA the whole square. Which means it will be root 2 into QA. That's what we got here also. So that means always it's better to learn more than one method. Okay, as I said, there is a mistake in the question here. It's supposed to be minus 2q. That's a mistake here. Only then you will have minus q and plus q here and minus q and plus q here. Any doubts here? I think it's an easy one. Okay, let me go to the next one. 23. A thin conducting ring of radius r is given a charge plus q. Electric field at the center O of the ring due to the charge on the part AKB. So that means because of this region they are asking AKB, the ring is E. So that means because of this alone the electric field I put here, it will be pushing the charges somewhere here this way, Because of these plus charges, it will get pushed this way. So that means the electric field is this way, E. Electric field at the center due to the charge on the part ACdB, which means the rest of it of the ring is obviously you know that if I consider this entire thing, the electric field at the center, listen carefully, very easy problem. If I put a test charge here, what will be the electric field? Anybody? Sharmila, Sandamil Shelvan, any answers? இங்க electric field என்னவா இருக்கும்? So electric field inside this will be 0. Why? Because this plus and this plus will repel, this plus and this plus will repel, this plus and this plus will repel, right? Because plus means, I mean, if I put a test charge here, what will be the force of repulsion? That is what is electric field. Which means because of this region alone, the electric field will be this way, which means the electric field because of this region will be opposite of this. So that means it will be like this. So that means it will be E along KO. Where is KO? KO is this way. That is wrong. So I think it should be OK, from O to K. So OK is correct. 2E, I think this is E, this should also be E, right? It cannot be 2E or 3. Only then it will cancel each other and it will become 0. So that means B will be the correct answer. Okay, let's try the next one. Problem 24. The mean free path of electrons in a metal is this much. Electric field which can give on an average 2 electron volt energy to an electron in the metal will be in the units of volt per meter. So, any idea how to do this? Electric field which can give an average 2 electron volt energy to an electron. If I take 1 electron volt, what is the meaning of that? It means the electron will gain, 1 electron gains electron will gain 1 volt, this much energy in 1 volt, right? 1 volt will gain 1 electron volt energy, right? So that's the meaning of this. So the energy gained by electron in 1 volt is what is called 1 electron volt. Mean free path of electrons, okay, the electric field which can give an average energy to an electron in the metal will be in the units of given average. So, volt per meter is electric field. So electric field vector is equal to head. So E is equal to V by D. So volt is, so that means it is having 2 volt here, right? As I said, 1 electron volt means it means you are applying 1 volt to get this energy. So if you are getting 2 electron volt, it means you are applying 2 volt. So that means 2 volt here, and the D is the mean free path distance. So that means it will be 4 into 10 power minus 8 meters. So this is your volt, this is meter. Electric field is, which can give an average. So that means they are asking to find the electric field. So simplify this, we'll get the answer. So 2 and 4 will cancel to become 0.5. 10 power minus 8 will become 10 power plus 8 volt per meter. Which means if I take one of the 10, it will be 5 into 10 power 7. So that's my answer. Okay, so you should remember this basic formula. Any doubts?
No, sir.
Okay. Electric field at a distance 3r by 2 from the center of a charged conducting spherical shell of radius r is E. So that's my sphere with the radius of r. So 3r by 2 means 1.5 times more than this, so somewhere here. So at this point the electric field at a distance of 3r by 2 is E. So that means electric field at this point is E, and this distance is 3r by 2. Electric field formula is kq by r squared. So k is electric field at a distance of r by 2 from the center of the sphere is, so at a distance of r by 2 means it is inside the surface. Conducting spherical shell. So since conducting spherical shell means inside, what did we study? Just even the previous question we talked about it. So if I have a shell like this, if I put a test charge here, this will be repelled by this plus. This will be repelled by this plus. That means both will cancel. Same thing will happen here. Same thing will happen here. Same thing will happen here. So that means the electric field inside a conducting shell is 0. So that means it doesn't matter what distance it is, since it is r by 2 is inside the shell, electric field is 0. Electrical potential V at any point, all in meters in space, is given by V is equal to 4x square. Electric field at the point is, so you must have studied, just now we studied a formula E is equal to V by D, but more accurately the correct formula would be E is equal to minus dV by dl. So this is the correct formula. Okay, more accurately, this is the formula. So that means at the origin, according to this formula, at the origin it will be 0, right? Because when I say x is equal to 0, v will be 0. So I think this formula can be extended as electric field E is equal to minus dv by dx in the I direction plus dv by dy in the j direction plus dv by dz in the k direction. Okay, so your vector algebra concepts will come here. So don't worry about it. Okay, I think it is given in your textbook also. So basically this is the general formula, but if you want to write it for each direction separately, then you have to write it like this. So that means if I differentiate the y and z, since I don't have a y and z here, it will become 0. So these two terms will become 0. Whereas if I differentiate the v with respect to x, I will get dv by dx is equal to 4 into 2 into x power 1. 2 minus 1 will become 1. So 8x. So that means minus 8x into I cap. As I said, if I differentiate with respect to y, um, this is actually like a partial differentiation. Okay, so it's coming in your mathematics later. So it's like partial differentiation. So that means when I differentiate with respect to y, x will be considered as 0. So that means this will become 0. Dou v by dou y will become 0. X is your at a location the electric field at the point 1 comma 0 comma 2. So that means x is 1. It means it is minus 8. Okay, very often I'll get questions like this. So very important method. Easy one only. So minus 8i. So that means the magnitude is 8, but it is in the negative x direction. So along negative x axis. So this will be the correct answer. An electric dipole of moment P dash is placed in an electric field intensity E. Dipole acquires a position such that the axis of the dipole makes an angle theta with the direction of the field. So that means let's assume that the electric field is horizontal. So let's say the electric field is like this. So they say that the dipole acquires a position such that the axis of the dipole makes, assuming that the potential energy of the dipole to be 0 when 90 degree. So that means dipole, let's say it's some direction like this, minus p. It means the electric field and this are at an angle of theta. So the potential energy of the dipole to be 0 when 90 degrees. So that means somewhere here it is 0. Potential energy is 0. Torque and the potential energy of the dipole will respectively be. So torque we have studied in the first chapter, tau is equal to P cross E, right? Tau P. So that means it will be Pe sin theta. And the potential energy, or I should call more accurately, it is rotational potential energy. It's not given properly. Rotational potential energy is U. So U is equal to minus P dot E. Okay, so go back and study these formulas, or it's all given in your handbook also. So minus P dot E, so that means minus PE cos theta. So that's why when it is cos 90, at 90 degree they said potential energy is 0. So that means according to this formula, if I take cos 90, this will become 0. Again, this is potential energy, this is P dot E. Okay, don't confuse. Don't think that this is potential energy. This is P dot E, meaning dipole moment multiplied by the electric field. So that means your answer is P sin theta and minus P cos theta. So that's my answer. Okay, very easy ones. They are just checking whether you know the basic formulas or not. Electric dipole of dipole moment P is aligned parallel to uniform electric field E. Energy required to rotate the dipole by 90 degree is. So I think again the same story what we discussed in the previous questions. Electric field is this way, aligned parallel to the uniform electric field. So that means the dipole moment is also along this way, minus Q plus Q. So that means it's aligned this way, minus P. Sorry, just P vector. So the energy just now we studied minus P dot E. So that means it will be minus PE cos theta minus PE cos 0, because this and this, the angle between them is cos 0. So cos 0 means it will become 1. So that means minus P into. So what this means is only if I give PE magnitude, I will be able to rotate it by 90 degree. Okay, to bring it here. Because at 90 degree the potential energy is 0. So that means PE will be the correct answer. So here why there is no minus, because we are talking about the magnitude. This may be a slightly longer question, so let's do it carefully. A toy car with charge Q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. So that means there is a toy car, the small charge of Q in this. So if I put electric field here, you know that because of the charge in the electric field, it will experience Q into E. F is equal to Q into E. Due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second duration. So that means in 1 second, the speed increases to 6 meter per second. So here it's 0 meter per second. Here it is 6 meter per second in 1 second duration. At that instant, the direction of the field is reversed. So that means suddenly the electric field is reversed, which means it is this way. So when I do that, what will happen? The same force which was experienced here will be now acting in the opposite direction. So force will also be reversed. So here F is equal to QE. Here I would say force is reversed. So now what will happen? Will the toy car move in the opposite direction or will it keep moving in the same direction? No answers. So from 6 meter per second, suddenly it cannot move in the opposite direction. So what will happen is it will move for some time to become zero. So that means it will take some time for it to become zero. So that means the velocity here will become 0 meter per second. Only after becoming 0 meter per second, then it will start moving in the opposite direction. The car continues to move for 2 more seconds under the influence of this field. The average velocity and the average speed of the toy car between 0 to 3 seconds. So that means for your understanding, I can redraw this over here. So 0 meter per second. So they said that it is traveling for 2 more seconds after this 1 second. But since this force and this force are equal, I think for it to become 0 to 6, it takes 1 second, means to become 6 to 0, it will take 1 more second. And after reaching here, it will start coming back. They said it is 1 more second, right? 3 seconds means 1 second here, 1 second here, and 1 more second here. Which means this will be moving with the velocity. Again, it will start moving at the velocity of 6 meter per second here. So the average velocity and the average speed of the toy car between 0 to 3 seconds. If you understood this part, after that this is very easy. Why? Because I know the formula for average velocity, because it is a total displacement by total time taken. You see the total displacement is, I can find out from here to here. And then total time taken is 3 seconds. Total distance traveled, I can, if I know this distance, that multiplied by 3 times. So that will be my total distance. So finding the average velocity and average speed is a very easy concept. But the problem here is we should understand this physics of the problem. This car is having a charge and it's moving this way. And then they said 2 more seconds. So that means because of the symmetry of the problem, if this is taking 1 second, they should also take 1 second to come to a stop. Only after stopping, it will start moving in the opposite direction. Okay. Just because you apply a brake doesn't mean the car will start moving in the opposite direction. It will come to a stop and only then you can turn around. So that means the same thing will happen here. Okay, so if you understood that, it's a easy problem. So after this, it's a very easy problem. So average velocity is equal to total displacement divided by total time taken. Total time taken, I know it is 3 seconds. But total displacement, I don't know this distance from here to here. Okay, how do I find it? I can find V is equal to U plus AT. And then can I use S is equal to UT or V squared is equal to U squared? 0 to 6 seconds. Okay, let me try V is equal to U plus AT. So V is equal to U plus AT. So V is 6, U is 0, A is, I don't know. Okay. T is 1 second. That means acceleration is equal to 6 meter per second square. So now if I want displacement, I can use v squared is equal to u squared plus 2as. V is 6 square, u is 0 square, 2a is 6. Displacement is what I want. Okay, so let's call this as displacement d, this distance. So this will be 36, 6 into 6, 2 into 6. So 6 and 6 will cancel, 6 and 2 will cancel. So I think it will become 3 meters. So that means I think this will be 3 meters, this will be 3 meters, this will be 3 meters. Why? Because the same force will be acting to stop it. So that means it will take 3 meters for it to come to a stop. And then the same force is pushing in the opposite direction. So that means for 1 second, in 1 second it will have reached the same speed and it will have the same displacement. So that means the total displacement is from here to here. So even though it has moved by 3 meters here, 3 meters here, and 3 meters here, the total displacement is only 3 meters. So that means it will be 3 meters. So that means 3 and 3 will cancel. So 1 meter per second. So 1 meter per second means either this or this. Once you find this, average speed is very easy. Why? Because the total distance is 3 plus 3 plus 3, so it will be 9. 9 divided by 3. So that means it is 3 meter per second. This is your correct answer. This is wrong. Okay, so for your advantage, maybe I can write quickly. Speed average is equal to total distance divided by total time. Total distance is 3 plus 3 plus 3 divided by total time is 3 seconds. That means it will be 9 divided by 3, so it will be 3 meter per second. So that's my answer here. Anybody having any doubts? Okay. If you have doubts, please raise it. Okay, only if you raise your doubt. Very often they will try to combine your mechanics knowledge with electrical knowledge. Okay, so this is a example where you should know your 11th basics and 12th basics. Only then you can attend this. An electron falls from rest through a vertical distance h in a uniform vertically upward directed electric field E. So that means the electric field is directed upwards. So that means this is plus and this is minus. That's the meaning of directed upwards. Electron falls from rest. So that means U is equal to 0. Electron is falling from rest this way. Why? Because this is plus, this is minus. So that it has to fall this way. In an electric field E. The direction of electric field is now reversed. So that means now suddenly you are changing the direction, which means it will be electric field will be this way. keeping its magnitude same. Proton is allowed to fall. So proton means you have somewhere, let's show a red color here. So proton will fall towards the minus. So this is also 0. So this is also having a distance of h. This is also having a distance of h. The time of fall of the electron in comparison to the time of fall of the proton. Any quick ideas? Which one will fall faster, proton or electron? Or same? A quick answer would be electron is lighter and proton is heavier. So electron will fall faster, I think, because acceleration is equal to F, which is Q into E. So E into E divided by mass. Why? Because F is equal to Q into E, which means the force experienced by the electron will be charge of the electron or charge of the proton, which is E into capital E electric field. That is also equal to mass into acceleration, which means acceleration is equal to E into E divided by M. Why should I know this? Because if acceleration is more, the time taken will be less. Right? So that means since the mass is less for electron, because this and this are same for electron and proton. Only the mass is, I think it will be like mass of proton is around 1800 times that of mass of electron. So that means mass of proton is very heavy compared to electron. So that means this is very low, which means acceleration of electron will be very high, which means the time taken will be very low. So the time of fall of electron in comparison to the time of fall of the proton is smaller. 5 times greater, 10 times greater. So these two are greater means both are wrong because it will fall quicker. Equal is also wrong. So that means you can directly say it is smaller as the right answer. Okay. So how do I know this? Well, you have to know the constants. Okay. So I told you many times, if you want, go to the handbook. The very first page, I given a lot of constants you should know. Yeah. So this page. So many things in electric topic, elementary charge, mass of a proton, mass of electron. I'm not sure where I given it. Yeah, you see, this is mass of electron, 9.11 into 10 power minus 31 kg. Mass of proton is 1.67 into 10 power minus 27 kg, which means you see the mass of electron is mass of proton divided by 1800. So that means it's a very light mass. Okay, so all the masses are given. So whenever you get some question based on proton, neutron, triton, alpha particle, neutron, so whenever you have some doubts, you can come back and check the charges and masses over here. Okay, so in the very first page, all the constants are given. hollow metal sphere of radius R, hollow metal, so that means it's nothing it's kind of empty shell of radius R is uniformly charged. The electric field due to the sphere at, so inside we studied many times in this class itself, electric field inside is zero, right? So electric field here is zero, but as you go out it will be, so we have studied this many times. So at the radius it will be high, and then as you go away from the sphere the electric field will drop according to 1 by r, sorry, 1 by r squared. Here in this region electric field is zero inside the radius. Okay, I think you can go back and check your handbook. I've told you many times that it's a very important topic. You should be aware of this. So if you want, I can show you where it is. So study it, and if you have doubts, I can help you. Yeah, this one. So you see, electric field is zero, and then as you go out, it will be 1 by r squared. For r less than r, increases is wrong. So that means this is wrong. 0 as r increases from, for r less than r, so that sounds correct. Decreases as r increases for r greater than r. Yeah, this sounds correct to me. 0 increases as r increases. Increases is wrong, right? As you go away, electric field will decrease, so that means this is wrong. Decreases both are wrong, so that means B is the correct answer. Very easy one, nothing very difficult there. Okay, let's see what they sent. Two parallel infinite line charges with linear charge densities plus lambda and minus lambda coulomb per meter are placed at a distance 2r. Distance of 2r in free space. What is the electric field midway between the two line charges? Okay, let's try to understand the situation properly with the diagram. Two parallel infinite line charges with linear charge densities plus lambda minus lambda. So that means this is like having a plus charge here, infinite line charges, and this is like having minus charges here. Placed at a distance of 2r in free space. So that means this distance is 2r. So now they are asking you what is the electric field midway between the two line charges. So electric field means what will happen if I put a test charge over here, positive test charge. Plus and plus will repel. Plus and minus will attract. So that means E1 and E2 will be in the same direction, which means it will not become zero, it will add up. And if you go back and study the formula, I think we found E1 is equal to lambda by 2 pi epsilon naught, the distance is r. So that is for this one. So E2 will be same because of the same distance. So that means the E total E net will be E1 plus E2, which is nothing but 2 times E1 because both are same, which means it is 2 times lambda divided by 2 pi epsilon naught r, which means 2 and 2 will cancel, so I will get lambda by epsilon naught r. So I think this will be the correct answer. Anybody, any doubts? Let's quickly finish this one, and then I think these are all easy stuff only, so you can do this as homework also. Question number 33. A spherical conductor of radius 10 centimeter has a charge distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Okay, I think it's a very easy problem, just direct formula substitution. So this is 10 centimeter. This is 15 centimeter. So what is the magnitude of the electric field? So electric field here will be kq by r squared. K is 9 into 10 power 9. Q is the total charge on the sphere, which is 3.2 into 10 power minus 7 divided by r squared. R is 15 centimeter, so that means it will be 15 by 100 the whole square. Simplify this, you will get the answer. So 10 power 2, 10 power 4, so 10 power 4 will go to the top. So 10 power 4 and 10 power minus 7 will become 10 power minus 3. So 10 power minus 3 and plus 9 will become 6. So 10 power 6 will be there in the top. And simplify this 9 into 3.2 divided by 15 into 15. Any quick answers? This will be approximately 5 times. I cancel this and this. I cancel with 3. This will be 3 times. This will be 5 times. So 3 divided by 25. If I multiply by 4, it will become 12 in the top. This will become 100 in the bottom. So that means it will be 12 into 10 power 4, which is 1.2 into 10 power 5. So that should be my answer. Electric field means Newton per Coulomb. 1.2 into 10 power 5. So that's my answer. So you see, you don't have to break your head, calculating this 3.2. I just took it as 3 and I'm still getting the correct answer. Okay, I've seen many students breaking their head with this, minute calculations, and they will make mistake in the 10 power. Instead, your focus should be on the 10 power should be done correctly. And this one you can do it approximately. Okay, so try to get the hold of this kind of approximate calculations. Okay, I think we have completed this topic. So electric flux and Gauss law topic 3 alone, you have very little problems. So from 34 to 43, 44, yeah, approximately some 10 problems, 10 or 11 problems. So very, very easy problems. So try it and come. We'll continue in the next class. Okay. So your job is, if you have any doubts in your school classes, you can ask me the doubts, okay, or you can send me the pictures. But I don't see you folks are doing that. Okay, I'm not sure how much you are studying in your school. So if some topic is not clear, you can ask me for help. Okay, we can discuss that. Okay, so I'm going to stop here. So any questions? Everyone okay? Following everything correctly? Sharmila,
Yes, sir.
fundamental. Okay, Veeran. Okay, thank you all. Bye.